Hi, welcome to the Physical Geology Igneous Rocks Identification Lab tutorial. And before you get started on this lab, you need to make sure that you have all the material that you'll need for the lab. And of course, you will need your igneous rocks. And so in your rock packet, rock and mineral box, there is a package that has igneous rocks in them. And you will need to make sure that you have the 10 igneous rocks, and you'll notice on your lab content sheet, it lists the igneous rocks, but it doesn't explain which rock is which, so they all have numbers on them, but you don't know which one of these names is associated with rock number 4. Other things that you'll need to complete this lab are the lab instructions, which are in the module for the lab, and there is the introduction. There'll be a link to the introduction for the lab, so you need to make sure that you read through that and you understand what you're going to be doing, and then you take the pre-lab quiz. So after you do the pre-lab quiz and you've read through the introduction and you feel confident that you've seen this video, then you will start trying to identify the igneous rocks that you have in your lab kit. So the sheets of paper that you'll need besides the lab introduction include the lab 2 worksheet, which is the diagram where you list the numbers of the rocks, number 4, number 9, etc. And then you fill out the lab worksheet with the appropriate information. What type of minerals are you seeing? Is it a mafic or felsic, intrusive or intrusive or extrusive? And then you'll be able to come up with the name of the rock. So you fill that out. Again, that's not something that you're going to be graded on, but it'll be extremely useful to have in front of you when you're completing the lab quiz. And what else do you need? Also in the lab introduction, there's a couple of figures and tables that you're absolutely going to need to look at in order to identify the rocks. And I will show you those at the end of this tutorial and help you to understand how to use those diagrams. So igneous processes, igneous rocks fall into two main broad categories, extrusive and intrusive. So just a reminder of what you should already know from your reading material. Igneous rocks are rocks that form as minerals crystallize or freeze from the liquid form. In other words, there's molten rock. It's called magma if it's below the surface, lava when it reaches the surface, and it crystallizes or starts to cool down so that the liquid becomes a solid. And it doesn't just freeze all at once, but it forms minerals within the rocks. Sometimes you can see the minerals easily, and sometimes you need to use a microscope in order to identify the individual minerals. So the first thing, one of the big things that we will look at is try to decide whether the rock you're looking at is intrusive or extrusive. So extrusive rocks mean that the lava makes it all the way to Earth's surface, and so it cools very quickly, days, maybe even hours before it turns into minerals, making up an igneous rock. And so since it cools so quickly, the minerals crystallize in the same shape, they have the same crystal structure, but they're smaller. So small that most of the minerals you're not going to be able to identify with or even distinguish from the other minerals with the naked eye. Again, you would have to use a microscope, which we're not using for this class. And intrusive rocks are those where the molten rock is still below the surface. It's called magma, and it's still cooling because it's surrounded by colder rocks, and so the heat escapes from the magma body, but it cools much slower, and it could take hundreds, thousands, millions of years for that magma to completely cool. That means that each mineral as it forms has time to grow larger. The crystals are larger, and the crystals grow in towards each other, and so they kind of fit together like puzzle pieces. So in these pictures here, this is an example of an extrusive rock. You can pick out a few little minerals that you can see with the naked eye, but the rest of the rock just looks like it's one color for the most part. Again, if you could look at it under a microscope, you'd see that it would look more like this, except the minerals in hand sample are so small. This is an example of an intrusive rock. You can pick out different minerals easily. You can distinguish them from each other. In this case, some are white and some are black, some are glassy and some are more opaque, and so you can tell that there's kind of bigger minerals. So when we identify igneous rocks, we're going to do it based on two main criteria. One is the composition of the rock, what minerals are present, and I'll talk about that in this slide. And then the second thing is the texture, and the texture is not the way the rock feels, but the way the rock looks, and that's determined dominantly or almost entirely by the size of the minerals or how the minerals are arranged in the rock, and that's what the grain size has to do with. But as far as composition, there's two main categories of chemical composition when we're talking about igneous rocks or lavas or magmas, and those are the felsic rocks and the mafic rocks. So the felsic rocks have, if you go remind yourself about Bowen's reaction series, felsic minerals are those minerals that have a lower melting temperature, and so they have different elements in them. They tend to have less, for example, less iron and magnesium in them, and higher amounts of silica and oxygen. And the mafic minerals that make up mafic rocks, those minerals have a higher melting temperature, and they tend to have, although all of these minerals have a lot of silica and oxygen, the mafic ones tend to have like more things like iron and magnesium. So all in all, those minerals and therefore the rocks are darker in color. So to sum it up, felsic rocks have more felsic minerals. The rocks themselves tend to be more light in color, perhaps light gray, pink, whitish colors. And the mafic rocks are made up of more mafic minerals, and the rocks tend to be darker in color, black or dark gray, sometimes green. So in this picture here on the slideshow, we see this rock up here is kind of a pinkish color, and so we would say that this is a felsic. If we know that this is an igneous rock, we would say it's felsic. This rock here, it's an igneous rock, and it's dominantly kind of a dark, very, very dark gray or black in color, so it's a mafic rock. So that's the chemistry. Sometimes we're actually going to have to identify the minerals, but in this case, these are extrusive rocks. The minerals are so small that we can't pick them out, but all in all, the rocks have this kind of color that helps us to determine if it's got mostly felsic or mostly mafic minerals. So as far as texture, we're going to break it up into two categories, intrusive and extrusive. When the magma cools slowly underground, the crystals have time to form large crystals, and they interlock. We say that it's a coarse-grained or phaneritic texture. Phaneritic texture, which means coarse-grained, which means that the minerals are large enough that we can differentiate them with the naked eye. For example, this one here on the slideshow, but here's one that I'm holding in my hand. Perhaps if the mineral lab is still fresh in your mind, you might recognize some of these minerals. I will point out that identifying minerals in a rock is a little bit more difficult usually than identifying the minerals when the minerals are just by themselves, like what you had to do for Lab 1. But you might recognize that this kind of pinkish mineral, that if you look at it and hold it up to the light, you can see that there's flat surfaces that reflect light well. So you might say to yourself, oh, it's got good cleavage and it's this pinkish in color. That might be potassium feldspar or K feldspar. So that's going to be helpful in identifying this rock. So even if you can't figure out what the minerals are, you can definitely see that there are large mineral crystals in this rock. Here's a couple of other examples of phaneritic or coarse-grained textured rocks. So they are also intrusive rocks. This one turns out, both of these are granitic rocks, so they have same or similar minerals in them, but the grain size is a little bit different. Like this one, the minerals are even larger than this one, but still, even though the minerals are a bit smaller than the other rock, you can definitely see the individual mineral crystals. To be able to identify these minerals, you might have to look a little bit more closely using a hand lens, which is in your mineral kit. So you're kind of moving the rock farther and closer. So you're not seeing the pink color, but you're seeing a lot of white colors. If you look closely, you see some minerals in it that don't have flat faces. They're kind of grayish in color, but they're light gray, and they're glassy. They let light pass through them, so they're not opaque. So there's actually quartz in this rock as well as in the other one. And this is another example of a phaneritic intrusive igneous rock. There's a higher proportion of dark colored minerals, so it's getting to be a less felsic rock. I think I have a sample here somewhere where almost all of the minerals in the rock are dark in color. And so this might look at first to you like that it's just all the same color, so how can you tell if it's coarse-grained or phaneritic, or if it's a really fine-grained rock where you just can't pick out the different minerals? Again, think back to your mineral properties. One of the really helpful mineral properties, hopefully, is cleavage. If you move the rock back and forth, and if you see there's a lot of kind of, even if they're small, little flat faces that are reflecting light, kind of like glass, then you can say that it's got some good cleavage to the minerals that make up the rock. And if you're seeing cleavage faces, then you're seeing the mineral crystals. And that means it's a coarse-grained or phaneritic rock. It's just since all or most of the minerals tend to be dark in color, that it must be more mafic rock. So a reminder, mafic and felsic refers to the composition, and phaneritic, in terms like phaneritic and aphanitic and vesicular and other terms that I'm going to talk about, refer to the texture, which is not the composition, it's not the minerals that it's made of, it's the size and arrangement of the minerals. So moving on to extrusive igneous rocks, ones that form when the lava makes it to the surface. Sometimes they're also called extrusive igneous rocks, are often called volcanic rocks, because when the magma makes it to the surface, it's called lava, and it forms landscape features such as volcanoes. So if you have a lava that pours onto the Earth's surface, and therefore the minerals have to form quickly because the lava is cooling relatively quickly, then it forms mineral crystals that interlock with each other, just like in this rock, but they're teeny mineral crystals. You can't see them individually with the naked eye. So you might find when you're looking at these kind of aphanitic, very fine-grained igneous rocks, you might see some minerals that you actually can see with the naked eye, but most of the rock consists of minerals that are too small to be seen with the naked eye. So this is an example of one, and it's dark in color. We can't pick out the individual minerals, but this is where color comes in useful. That's dark, so this is probably an aphanitic or fine-grained mafic igneous rock. And so if I were to ask you, is this intrusive or extrusive? Well, it's extrusive. If the mineral crystals are so small that I can't see them, that means the lava cooled quickly, so it's an extrusive rock. Okay. So here's an example of an extrusive igneous rock that is considered, would probably be considered aphanitic, but you are seeing more large mineral crystals in it. So for example, I don't know if you can see this in the video, but it's this kind of rectangular looking white mineral, so it's got the crystal shape. But one thing that's very distinctive between these two is the color difference. This is felsic, this is mafic. That's composition, but as far as texture, they're both aphanitic or fine-grained rocks. They're both extrusive. So here is a picture of an aphanitic extrusive rock, but it's a picture if we could take a very thin slice of a rock like this, and so thin that light can pass through, and look at it under a microscope, then you can see the individual mineral crystals. You just can't see them with your naked eye. So different things can happen when lava comes to the surface. So the texture of extrusive rocks is not always fine-grained, or in other words, aphanitic. There's another texture that's kind of in between aphanitic and phaneritic. So let's say that you have a magma below land surface, deep underground, and it starts to cool very, very slowly. And some of the minerals that have a higher melting temperature, they form first. So you kind of have this magma soup with some chunks of mineral crystals in it. Maybe they've been forming for a long time, so they get really large. Then something happens, and that magma goes up to the surface. It's got some solid mineral crystals that are pretty big, but the rest of it is still in liquid form. And it makes it to the surface, and the rest of that liquid has to cool very quickly. What does the rock look like? Well, it might look something like this. This texture is called porphyritic. That means we see some really large mineral crystals. Definitely, these are huge ones. These are very easy to see with the naked eye. But if you look in between them, the what we call the ground mass, or the other minerals that are around these big ones, are not big enough to be seen with the naked eye. So the really large crystals, and it's usually going to be one, maybe two types of minerals, because they have different temperatures at which they can form. These really large ones, we call them phenocrysts, which means large crystals. So the root word crystal refers to crystal, so you know we're talking about a mineral, not a rock. So these are large minerals, or phenocrysts, in a fine ground mass, meaning the other minerals are teeny. So that's an example of one. Here's another example of one where you can see these light-colored large mineral crystals that formed underground, but before the entire rock could cool, the magma came to the surface, and the lava became lava. We refer to as lava, and that cooled quickly, forming small minerals, microscopic minerals, around the large solid crystals that had already formed. So that texture is porphyritic. The large crystals are called phenocrysts. And when we're trying to identify rocks like this, it becomes useful to identify what is the type of mineral, what is the name of this mineral, and that will help us identify the name of the rock. I've just given you the texture. It's porphyritic, but we still don't know what kind of rock it is. We don't know the name of the rock yet. We'll get to that in a moment. This texture is pretty easy to identify. It's called glassy texture. And this is what happens if a lava comes to the surface and cools so rapidly that the elements in the lava do not have time to the atoms don't have time to arrange themselves in an orderly, repeating crystalline structure. So that means this is a rock that does not have minerals in it. It's made up of glass. Glass is a solid, naturally occurring, inorganic substance. It meets a lot of the criteria of a mineral, but it does not have an orderly or crystalline atomic structure. It's random. That's why when you break glass, unless it's tempered glass or has been modified in some way, if you break glass, it just breaks randomly. You get a lot of sharp shards and chunks of glass that form. So there are rocks that are not made up of minerals, and this is one example of that. This is a glassy texture. Again, the lava cools very, very quickly. Now you'll notice that most of these glassy rocks are very dark in color. They're either black, or some of them I've seen dark brown, mahogany colors, but that does not mean that they're mafic. This is an exception to the color rule. They're dark in color because of the glassy nature to them. So actually this is a felsic rock, ironically. Another texture that happens in an extrusive environment. So let's say you have a magma that's coming towards the surface. So the lava's at or near the Earth's surface, and there's a lot of gases dissolved in the lava. What I mean by that is that they haven't formed bubbles yet. And as the lava comes to the surface, it's under less pressure, and the bubbles come out of solution. And normally the the air bubbles, would rise up above the top of the lava and escape into the atmosphere. But they don't always have a chance to escape. So sometimes the lava will cool quickly around those trapped air bubbles. And now you have trapped air bubbles inside of a solid. The air, eventually can escape, but it leaves behind these air pockets. The air pockets in these rocks are called vesicles. And the texture of the rock is vesicular. So it's an extrusive igneous rock. Sometimes it's glassy, but it won't look glassy. The this texture is pretty easy to identify for a couple different reasons. One is very often you'll see, an example, you'll be able to see the large kind of vesicles or cavities in the rock. And another reason that we can identify this texture is that the rocks are very light. They're very low density because there's a lot of space. It's not solid rock, it's a lot of air moving through the rock. So there's, again, this vesicular extrusive rocks can have different composition, whether the lava is mafic or felsic. These vesicular rocks will have different colors. Okay, so those are the main textures of the igneous rocks, and once you understand the textures and you understand the concept of mafic versus felsic and the fact that some minerals are more mafic and some minerals are more felsic, now we can actually determine what the name of the rock that we're looking at. And especially true with intrusive igneous rocks, that we need to be able to identify at least some of the minerals that we're looking at. And then once we do that, we need to have a rough estimate of what percentage of the rock is made up of those minerals. So for example, I'm going to come back to this potassium feldspar example. A lot of these large minerals, it doesn't matter the size, but I happen to be able to see them very well. They're pink in color and they have these good cleavage faces on them. I move them back and forth in the light. They are reflecting the light kind of like a flat glass plane. And so that tells me it's potassium feldspar or K feldspar. And so I look at this rock and I want to try to figure out what percentage of this rock is made up of that mineral. That's kind of a tough thing to do, and there's different methods that different people like better than others. But you can use this diagram here, which is in your lab introduction package. So it has this kind of if you take this kind of a little area of your rock and you compare it to these diagrams, then you can kind of guesstimate what percentage of the rock is made of these minerals. So the dark areas on this part of the diagram, for example, compose about 10% of the circle, whereas in this area, the dark is about 50% of the circle. So in this one, the pink, it's a little subjective, but I would say it was something roughly about 30%, 25%, 30%, something like that. So that's one example. So when you're looking at these intrusive rocks with the large crystals, try to identify 1, 2 of at least of the minerals and get a rough idea what percentage of the rock they make up. And then the diagrams will help you to identify the rock. And this is one of the diagrams that's very important in identifying rocks, and it looks kind of complicated when you first look at it, but if you take the time to understand what it means, it'll be very helpful in identifying the rocks. So let's start up here at the top. It says light versus dark color. And then if you go to the bottom, you notice it says felsic, mafic, ultramafic, and then something in between. So as I said before, felsic rocks tend to be lighter in color. Mafic and ultramafic rocks, which we won't be looking at ultramafic rocks as a rocks that were generally found in the mantle or start out in the mantle. They're very dark in color. Mafic rocks are dark in color. Okay, the next thing I want you to look at are these two rows here. This row refers to aphanitic or porphyritic rocks, the texture, and those textures occur in extrusive or volcanic rocks. The phaneritic texture, the coarse grain texture, those occur only in intrusive rocks that form below Earth's surface, so the minerals get really big. So that's what these two rows refer to. Then you come down to this area here and you see the minerals that you're going to be looking for in the rocks. So you've looked at, I believe, most of these minerals earlier, but you'll notice that there's only there's about roughly 8 minerals that you should be familiar with when identifying igneous rocks. These are the more common igneous minerals. So let's say you look at your rock, if we can go back to this example again, and you determine that there's a decent amount of potassium feldspar in it. You find potassium feldspar in this chart, and it takes up this kind of polygon on the chart. So that tells us that if the rock has potassium feldspar in it, it can be I'm going to go up. It can be granite, it can be rhyolite, or if it's got a little bit of potassium feldspar, it can be granodiorite or dacite. So I determined that there was a decent amount of potassium feldspar, so I'm going to say that this rock is probably granite or rhyolite. How will I know whether it's granite or rhyolite? Which one is it? Okay, the potassium feldspar helps us to understand the mineral content and therefore the composition or chemistry of the rock. But these two rows refer to the texture of the rock. Phaneritic, coarse-grained. This is a coarse-grained phaneritic rock. Got a lot of potassium feldspar. I can also see some gray, glassy minerals in it that have kind of uneven surfaces because they have no cleavage. It's got a decent amount of quartz as well. So I'm going to say that this rock is granite. A lot of quartz, a lot of potassium feldspar. These are biotite's a black mineral, amphible's a black mineral. So granite is going to have at most less, maybe roughly 20% or less black minerals. And I would say that that is the case here. So that's how you use the chart. If you find a rock and it's got only dark minerals, but they're coarse-grained minerals, they have these cleavage faces, it's probably going to be mafic, unless we're not looking at ultramafic. So it's probably going to be mafic, maybe intermediate. Hopefully you can try to identify some of these minerals. Calcium-rich plagioclase is going to be darker in color than sodium-rich plagioclase, which will be kind of more of a tannish color. This can be much darker, green or black. Pyroxene is black. Olivine will be green. But if it's a mafic rock and it's, again, phaneritic, then it's probably gabbro. Whereas if it's a dark rock, but you cannot see the minerals in it, or most of them, then it's aphanitic, basalt. Now, in this case, I can see a few mineral crystals, not very many, so I would not say that this is porphyritic. This is aphanitic. Remember, with the aphanitic rocks, most of it is microscopic in size, the minerals are, but you do see the occasional small minerals, but large enough to be seen with the naked eye. And it turns out that I can pick out that these are glassy green minerals, and I happen to know that that's olivine. So that fits. It's mafic, dark in color, and I happen to be able to see some olivine in it, and olivine fits in here. Then it's not coarse-grained, it's fine-grained, aphanitic, so it has to be basalt. So that's how that works. So this is going to be most useful. This chart here will be most useful in identifying the phaneritic rocks, the intrusive granite, granodiorite, diorite, gabbro. To identify the aphanitic, porphyritic rocks, it can be useful, but if you want to identify vesicular or glassy or other extrusive volcanic rocks, then the next diagram is going to be even more useful. So again, this diagram, table 2, does not work for intrusive rocks, it's just extrusive rocks. So the texture could be aphanitic or porphyritic, which is also listed on the previous table, but this summarizes it again. Or it can be glassy in texture, or it can be vesicular. And here it says vesicular and glassy, but it's going to be hard to see the glassiness because it's kind of smaller surfaces, so just look for vesicular. So aphanitic, porphyritic, large crystals in a fine ground mass, glassy, vesicular. So how does this work? So let's say you find a rock and you think it's vesicular. It's got a lot of vesicles or air pockets in it. So then you might ask yourself, okay, there's two basic rocks. They're extrusive or volcanic rocks. They're both vesicular, but they have two different names. How do I know which one this is? It's very low density, so I'm pretty convinced it's vesicular. How do I know whether this rock is scoria or pumice? And then you have to think about the composition. Is this a felsic or a mafic rock? So you can go over here and see. The mafic rocks that are vesicular are going to be dark gray, black, or reddish brown. And those are intermediate or mafic, and that rock will be called scoria. If it's light in color, a gray, pale gray, white, pink, it's going to be felsic or felsic intermediate, and we group that together. We call all of those pumice. So what do you think about this one? Scoria or pumice? I'll let you decide. If you run into a glassy rock, for the purposes of this lab, these are just the common ones. It'll be obsidian. If it's aphanitic or porphyritic, then you have to kind of compare the color and therefore the silica content to determine whether it's felsic, felsic intermediate, or mafic. Okay, and so that's a summary of how we go about identifying the kind of major igneous rocks. So definitely refer to this, refer to the introduction explanations in your lab, refer to your readings from your text in the reading packet, and have fun identifying your igneous rocks.